Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to divide polynomials. But before we get into it, let's go ahead and have a brief review of the laws of exponents. Remember that when we're multiplying the same base, we're going to go ahead and keep the base and add the exponents. Okay, so that's the multiplication property. Remember that when you're raising a power to a power, you're going to go ahead and distribute the outside power to every exponent. Remember the invisible one exponent law. You're going to distribute that n to everything. And if it's in a fraction, you also distribute the outside exponent to every exponent inside. Okay? For division of monomials, when you're dividing the same base, remember that you're going to keep the same base and subtract the exponents. Remember that with negative exponents, you can turn a negative exponent into a positive by simply bringing it down to the denominator. Or if the exponent is negative in the denominator, you can simply move it up to the numerator to make it positive. And when you have a fraction inside of as a monomial being raised to a negative power, you can go ahead and reciprocate the inside, go ahead and flip it, and the signs will change. And anything to the zero power will always equal 1. Okay, so now that we have that little review out of the way, let's go ahead and talk about what I call the distributive property of monomials. The distributive property of division is when you're going to go ahead and divide the denominator to every single term in the numerator. It's that simple. It's just like the distributive property of multiplication. You multiply the outside value to everything inside. Here, you're going to go ahead and distribute via division the denominator to every single term on the numerator. So for example, here we're going to go ahead and take this 4x squared and we're going to divide it to every single term. Let's go ahead and show what's going on here. So I have 12x to the fourth divided by 4x squared plus 24x cubed divided by 4x squared plus 4x squared divided by 4x squared. So let's rock and roll here. We've got 12 divided by 4 is 3, x squared, x to the fourth divided by x squared. Remember 4 minus 2 is x squared. Remember that when you're dividing the same base, you keep the base and subtract the exponents. 24 divided by 4 is 6. X cubed divided by x squared is 3 minus 2 is 1. So we've got x. And then 4 divided by 4 is 1. And x squared divided by x squared is 1. 1 times 1 is 1. Anything divided by itself is 1. And there you have it. That is the distributive property of division. Okay, now, when we're dividing a polynomial by a binomial, okay, we're going to write both the numerator and denominator, first of all, in standard form. Please remember that standard form means I'm going from highest exponent to lowest exponent. And then let's remember basic division, okay? Now, let's go back in time. If we have 579 divided by 16, the 16 is going to go on the outside. The 579 is going to go on the inside. Okay? 16 goes into 47 3 times. And 3 times 16 is 48. I'm going to go ahead and subtract my value here. Okay? Just like regular division, like we've always done when we were young kids. All right, so we're going to go ahead and go 57 minus 48, and that's going to give me 9. Drop down the 9. How many times is 16 go into 99? And that's going to be 6 times. 6 times 16 is 96. And I'm going to have a leftover or a remainder of 3. So this is going to be 36 with a remainder of 3 over 16, right? Or we could write that mixed number 36 and 3/16. Now, you may say, why are you doing this? Because these exact same procedures, okay, are going to be used for this example number 2. I promise. So if you understand basic division, you're going to understand this. Take my word for it. Let's go ahead and do the example. So I have x squared plus 10x plus 21 divided by x plus 7. First and foremost, remember that the denominator always goes on the outside. And remember that the numerator goes on the inside. Now, when we're dividing, just like in the example 579 divided by 16, we asked, how many times does 16 go into 57? Well, we're going to use a very similar pattern here, but we're only going to be working with the leading term of the denominator. Okay? That's the one that we're going to use to ask questions. For example, how many times does x go into x squared? Just think about it. Pull it to the side here. X squared divided by x, oh, it goes in x times. Okay, so now, remember that we have to subtract the product. Okay, we're going to subtract the product. That's just from regular division. If you look back up here, when we went 3 times 16, it was 48, and we're going to subtract that. Okay, so what I'm going to do here is I'm going to make life easy. Since we're going to subtract the product, to not make it a messy situation, when we're going to go ahead and multiply here, we're going to do what's called negatize. Negatize. That's the act of multiplying something by -1. Why are we doing that? Because we're going to subtract the product. So x times x is x squared, but we're going to negatize it because we have to subtract the product. So that's negative x squared. X times 7 is 7x, but we're going to negatize it, so that's negative 7x. The first term will always cancel. If not, you made an error. Go back to the drawing board. This is 3x plus 21. Back to my original x. How many times does x go into 3x? It goes in positive 3 times. 3 times x is 3x. Negatize. 3 times 7 is 21. Negatize. And in this case, there is no remainder, and my answer is x plus 3. It's that simple. Let's do another example. 6x squared plus 9x minus 10 divided by 2x minus 1. Okay, 2x minus 1 is going to go on the outside. That is my denominator. And 6x squared plus 9x minus 10 goes on the inside. Remember that we're working with the lead term, the leading term of the denominator, written in standard form. So 2x goes into 6x squared 3x times. How did you do that, Moto? Because 6x squared divided by 2x equals 3x. So it goes in 3x times. Let's go ahead and multiply and negatize. 3x times 2x is 6x squared, but we're going to go ahead and multiply it by a negative, so it becomes negative 6x squared. 3x times -1 is negative 3x, but we're going to go ahead and multiply it by a -1, so it becomes positive 3x. First terms cancel. 12x minus 10. 2x goes into 12x, positive 6 times. 6 times 2x is 12x. Negatize, that becomes negative 12x. 6 times -1 is negative 6. Multiply by a negative, that becomes positive 6. And I have a remainder of negative 4. So I write that remainder as plus negative 4, which is my remainder, over my original denominator of 2x minus 1. I promise you that with practice, this becomes extremely simple. Okay, now, one last little pro tip. You can always divide the long way, okay, I promise. However, you can use a very powerful way to divide called synthetic division. If and only if the leading coefficient, okay, of the divisor is 1 and the exponent is also 1, okay? Remember to always write in standard form and always fill in missing values with a 0. Missing values, what do you mean? Let's say I go from x to the 4th, then x to the 3rd, but then I go to x. That means I skipped x squared. I got to put a 0 there. So, okay, let's check this out. First off, when we're doing synthetic division, we're going to look at our divisor and we're going to set it equal to 0. And we're going to solve for x, and x is going to equal 1. That is now my root. So I have a 1 that I'm going to put on the outside to this little inverted L. And now I'm going to write all of the coefficients of my numerator. Remember that coefficients are the numbers being multiplied to the variable. So there's a 1 for the x to the 4th. There's a negative 2 for the x cubed. There's a 1 for the x squared. There's a 1 for the x. And I have a constant of negative 1. I wasn't missing any exponents, so I didn't have to fill in any missing values with 0. Okay, now here we go. Remember, you can rewind this to learn it. First thing you're going to do is you're going to drop down the first digit that you have. And now you're going to multiply the root, or the 0, times this 1. The product you're going to add to this negative 2. Negative 2 plus 1 is negative 1. Now you're going to multiply the 1 again times this negative 1 and add the product to this next term, which is 1. 1 minus 1 is 0. You're going to multiply that 1 to the 0, add that product to this next 1. 1 plus 0 is 1. And then you're going to multiply 1 times 1, add the product to this last value, giving me 0. When the last value is 0, I have no remainder. Okay? Now, what do I do with all of these values, Moro? Okay, let's think about this logically. We just divided, okay, a polynomial of 4th degree by a binomial with a degree of 1. Remember that when we're dividing the same base, you subtract the exponent. So all of these guys here in yellow that I'm highlighting again, those are the coefficients and constants of the new polynomial that we formed, starting with 1 less degree. So that first green 1 is 1x to the 3rd power, because 4 minus 1 is 3, followed by minus 1x squared, followed by 0x, followed by a positive 1. So my answer would be x cubed minus x squared plus 1. Trust me, this is actually easier than long division. Let's do another one. Okay, first off, we're going to go ahead and write this in standard form. So this is going to become x squared minus 16x plus 70 divided by x minus 9. I'm going to go ahead and put my x minus 9 set equal to 0. So 9 is my 0, my inverted L, my coefficients, 1 for the x squared, negative 16 for the x, my constant of 70. I'm going to go ahead and drop down the first term. Then I'm going to multiply 9 times that first term. Add the product. That's going to be negative 7. 9 times negative 7 is negative 63. And I have 7 left over. Remember when I told you there was nothing left over, there's no remainder. Now the last number will always be the remainder. Now, how do we write this answer as a polynomial? Remember that we started with a power of 2. We divided by an x, so we're going to subtract one exponent. So this green 1 is 1x minus 7 plus my remainder of 7 over x minus 9. Remember, you can rewind and rewatch it. Thank you for watching. I hope this helped a lot. Come back anytime. Tomorrow's Math Corner. Take care now. Bye-bye.